Hello all, we will look into how to solve some problems in combinational logic circuits today. So let us get into the first problem. So here it says implement the given Boolean function f of ABCD is equal to 1, 2, 4, 7, 10, 13, 15 using decoder. Okay. So basically it is summation of, so that is min terms. Okay, let us consider it as min terms. Okay. So f is the function which has 4 inputs ABCD and it is summation of 1, 2, 4, 7, 10, 13, 11, 13 and 15 using decoders. Okay. So we are supposed to implement this particular combinational logic circuit using decoders. So here first thing is we have to decide which decoder do we have to use. As discussed earlier, decoder circuit depends on the number of inputs. So we have 4 inputs here. So we will be designing 4:16 decoder. As discussed, for n inputs we will have 2 power n outputs, right, for a decoder circuit. So as we have 4 inputs ABCD, we will have 16 outputs, that is 2 to the power of 4. So we will be using 4:16 decoder, 4:16 decoder. Okay. Now first we will have to count the number of inputs given in the function, that is there are 4, for which we need n is to 2 power n decoder, that is 4:16 decoder, and then at the end we require OR gate because that is summation. Okay. Now when you look at this particular diagram, this is a 4:16 decoder where we have 4 inputs A, B, C, D with 16 possible outputs labeled from 0 to 15. Okay. Now for this particular, if you want to implement this particular logic using decoder, what we simply see, decoder is all about what? AND gates, right? So each of them represents min term, and for that, for combining all the selected min terms, we require an OR gate. Okay. So 1, 2, 4, 7, 10, 11, 13, 15. So 1, 2, 4, 7, 10, 11, 13, 15 are together given to one OR gate because decoder has all AND gates together. So each min term represents one AND gate, and for selecting all the min terms and adding them together, we require one OR gate. So this is how we implement, this is an enable input, that is optional. Okay. So this is how we implement this particular Boolean function using a decoder circuit. Okay. Now the next problem is, for the combinational logic circuit, a combinational logic circuit is specified by the following Boolean functions. Okay, we have 2 Boolean functions here, F1 and F2, which has 3 inputs each. Okay, for each input few of the min terms are given. In the first case it is F1 of ABC where the min terms are 2, 5, 6, and in the second case we have 3 inputs again ABC for which we have 3 min terms which are 1, 3, 4. Now what is the size of decoder that we have to choose? Okay, so as we have 3 inputs in both the functions ABC, we will be going for 3:8 decoder because n is to 2 power n, 3 inputs into 2 power 3. So 3:8 decoder. Okay. Now when you look in this diagram, we have 3 inputs ABC, we have 8 possible outputs labeled from Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. In the first case we have 2, 5, 6. Okay. So 2, 5, 6 given to OR gate, that is F1, 1, 3, 4 given to another OR gate, that will be F2. Okay. So as each min terms represent one AND gate which are already available in the decoder, we are just using that particular output of AND gate and giving that to OR gate. Okay. Next, implement the function f of ABCD is equal to summation of m 2, 3, 4, 5, 8, 9, 12 using 16:1 mux and also using 8:1 mux. Okay, this is another twist question. Okay, the first case we can solve it directly because the given input function has 4 inputs A, B, C, D. So when you want to implement that by using multiplexer, we use 4:1 mux because there are 4 inputs. But along with that, they are also asking us to implement using 8:1 mux also. So we will see how to design this particular problem using 16:1 and 8:1. Okay, so for 8:1 mux, we will have 4 selection lines and 1 output as we have known earlier, and these are the possible min terms that are given for which we have to design the logic circuit. Okay. First let us look into how do we design using 16:1 multiplexer. So for 16:1 multiplexer we have 16 inputs, 4 select inputs ABCD. For 2 to the power of n inputs we have n select inputs, right. So 16 inputs n select inputs and only one output. Okay, so when you talk about designing the multiplexer, we have these minterms 2, 3, 4, 5, 8, 9, 12. So the inputs corresponding to the minterms are connected to logic 1 because they are the ones which I want to use. Okay, so the inputs which are given in the problem will be connected to logic 1 and the remaining inputs will be grounded. This is how we design any combinational logic circuit, logic function using multiplexer. So the inputs which are given 2, 3, 4, 5. Okay, so 2, 3, 4, 5, 8, 9, 12 are connected to logic 1 and the remaining inputs are grounded. So these are the selected inputs. Based on the combination of select lines, one of this input will be appearing at the, one of these selected inputs which are connected to logic 1 will appear at the output. Okay, so this is about 16:1 multiplexer. Now when I talk about same implementation using 8:1 mux. Okay, so as per the question, we are supposed to implement using 8:1 mux. So for 8:1 mux, we will have only 3 select lines, right? So when I talk about 3 select lines, I will have only B, C, D. Okay, but here I have 4 inputs which are A, B, C, D. Okay, so what we do here is we will derive the 8 inputs of the 8:1 multiplexer using the implementation table. So here we are introducing this new concept called as implementation table, where we will use the implementation table when the number of inputs are more, but the circuit that we are choosing has less number of inputs compared to the inputs given in the problem statement. Okay, did you understand? So here in the problem I have 4 inputs A, B, C, D, for which these 4 inputs are taken as selection lines. But when you go for 8:1 mux, where we have only 3 selection lines, I cannot accommodate all these 4 inputs, right? So in that case we will be going for implementation table. Okay, so this is the implementation table. When you look at that, in the implementation table I have D0 to D7 as inputs and I have 2 rows. One is A row and A bar row. Okay, so here I am having BCD lines, but my A line is missing, right? So for A line, I have D0 to D7 with A as 0 and A as 1, that is A and A bar. Okay, now first I will label all of them 0 to 15 and whatever the input minterms are given, okay, 2, 3, 4, 5, 8, 9, 12, I will circle them in the implementation table, 2, 3, 4, 5, 8, 9, 12. Okay, first I will take the implementation table with D0 to D7 and the remaining input, that is A and A bar, all 15 minterms covered. Okay, after that, depending upon the problem statement, whatever the minterms are given, we will just circle them. Okay, now after you circle them, now compare each of the output columns. Okay, now when you look at this particular thing is circled. Okay, out of A and A bar, this particular 8 is circled here which belongs to A. So hence I write the output as A. Here in this case 9 is circled which belongs to this row. So it is A. Here in this D2 case 2 is circled which is belonging to A bar row. So A bar. In this case 3 is circled which belongs to A bar row, hence A bar. Now when you have both of them circled, then A into A bar is equal to 1. So here in this case 5 is circled which is A bar. When none of them are circled, we put it as 0. So there are 4 cases. Okay, when both of them are circled, A and A bar gets cancelled and we get, A and A bar we get its 1. When none of them are circled, we get cancelled, A and A bar gets cancelled, hence the output will be 0. If one gets circled, check for that particular row. Okay, so here it is 8 which is there in A row, hence it is this. When you look at the D2, 2 is circled in A bar row, hence the output is A bar. So we will use the implementation table when the number of inputs are more in the given problem, but we are asked to design that using less number of input gates. Okay, now when you look at this 8:1 multiplexer has 3 selection lines which we label them as BCD. They have 8 inputs D0 to D7 and for which I am going for A line, A bar line, 1 line, 0 line. Okay, now look at this. D0 is connected to A, D0 is connected to A, D1 is also connected to A, D0 and D1 are connected to A, D2 and D3 are connected to A bar along with D5, D2, D3 and D5 are connected to A bar, D4 is connected to 1, D6 and D7 are connected to 0. Okay, so Similar to this, you may be given a 5 variable function, that is f of a, b, c, d, e is equal to some minterms. Implement that using 16 by 1 mux, 32 by 1 is directly a, b, c, d, e, 5 select inputs. So 32 by 1 mux we can do it directly. If they ask you to design f of a, b, c, d, e with 16 by 1 mux or 8 by 1 mux, then we have to go for implementation tables. Okay. So this is how we design the combinational logic circuits using the given functions. So you may be given a function and asked to design the combinational logic circuit using decoders, using multiplexers or code converters, comparators or any other logic circuits. With this we end unit 4. Thank you.